Hello again, guys. In this lecture, we are going to look into inheritance in action in Python. Now, first, just to recapitulate, we learnt in our OOPS concepts that inheritance is a basic aspect of the object-oriented programming paradigm. So, to illustrate with a very basic example, we discussed that we all are childs of our parents, right? And we inherit some of the properties for both of our parents, like some of them speak like our mothers, some of them walk like our fathers, right? And things like that. But we do have our own specific attributes as well. So there may be some specific attributes which are not there in both of our parents, but it's specific to us only. But we do inherit some of the properties from both of our parents, and that's what is known as inheritance. And we also learnt in programming paradigm the parent classes from which we inherit something are known as the parent classes or super classes. And similarly, the classes which are inheriting the attributes or behaviors from the parent classes are known as subclasses or child classes. So over here we are the child and our parents are the parent classes from which we are derived from. Now to extend this to our vehicle example that we have been discussing so far in all past lectures. So let's extend it a bit. So let's start with the car class over here, guys. And in this car class, it's a generic blueprint of a car design. So we can consider it as a parent class in this case, and it has some general attributes like start, stop, and brake, which every car should have. A car does not qualify as a car if it does not have these three attributes at least, right? Or these three behaviors at least. So from this car base class or car parent class, we can actually have two subclasses. One of them is Mahindra, okay, which is the kind of base class for all Mahindra cars. And similarly, we can have a base class Audi, which denotes all Audi cars, guys. Now, these two classes under inheritance concept of object oriented programming would inherit all the common behaviors that the parent class show, which are start, stop, and brake. So both of these classes will have this start, stop, and brake behavior with them because they have inherited this behavior from the car class. So they don't have to define these methods within themselves, but they would inherit it from the parent class itself. But since Mahindra and Audi are two separate types of cars, they are free to define their own methods and attributes as well. Just like we as individuals have some specific attributes apart from our parents, right? So, in a similar way, Mahindra and Audi can define their own attributes, which I have denoted over here as Mahindra is generally famous for guys making trucks, 4x4 cars which can run on any terrain like hills, sands, and things like that, right? So I have put a method like 4x4 mode which is available only to Mahindra cars. And similarly in Audi we have a sports mode that is available only for the Audi group of cars. So these two methods are not available in the generic car design because all the cars don't have this mode. However, anyone who is extending or inheriting from this car base class would not have to at least worry about the base functionality like start, stop, and brake because it actually inherits those behaviors and properties from the base class itself. It just have to worry about writing the logic for its own specific characteristic, which is 4x4 mode in case of Mahindra and sports mode in case of Audi. Now, inheritance can be again extended to further subclasses. It's just like a chain. So from Mahindra base class or Mahindra as a parent class, we can have couple of child classes which inherit from Mahindra. So they all have start, stop, brake, and four cross mode, just like these two famous models of Mahindra, XUV 500 and TUV 300. However, they again can differ with each other based on some specific attribute, like say TUV 300 has a 40-liter tank capacity, fuel capacity. On the other hand, XUV 500 would have 70 liters of fuel capacity. So in that attribute or that functionality or that method, it can define within its own class. In a similar way, Audi A4 and Audi A6 may differ in automatic transmission or manual transmission, right? So they can define those methods within themselves. However, they don't have to worry about the common behaviors which every Audi car should have, that is start, stop, brake, and sports mode. So they would inherit it by default and they don't have to write it by themselves. So that's inheritance working with our own example, guys. Now, an advantage of this functionality is that in terms of programming, if you have written the code required to implement the start, stop, and brake method in the base parent class itself, you don't have to write it in the other two classes that you are defining, like Mahindra and Audi. So that removes code redundancy, which was the case with procedural programs, guys, leading to function scattering all over the place, lines of code scattering all over the place. And if there is a change to the start logic, you just have to change it in the parent class itself, and that change would automatically take place for all the other subsequent subclasses that inherit from the parent superclass called car, guys. So that's the most powerful feature that object oriented programming brings to you. In the next section, we are going to discuss about in detail how the inheritance works with Python, what are the syntaxes involved for implementing a basic inheritance, and we are going to finally have a hands-on session on inheritance wherein we are going to run an example.